In this video, we will look at functions. Functions are very useful because they allow you to create your own special customized commands that do a series of tasks within the command when we call on them. So let's look at the functions. Here we are in Robot C. We have a pragma data at the top and a discussion of this program there in the comments. This program is very simple of writing functions to move forward, backwards, right turn, and left turn. So let's look at the components of a function. Lines 8 through 17 comprise the function for forward. We start off by writing void. We name our function. And inside the function's parameters, which we always, even if we didn't want to have any parameters, you still have to put both the parentheses. But inside the parentheses, we can put parameters, and we create an integer type variable called forward time. We'll see how we use that later on. So for forward, I have it do all of these tasks. I set the motors to 75. I wait for the forward time. After the forward time has completed, I turn the motors off, and I'll wait 1 second before leaving the function. I do the same thing for void backwards, but notice I create a variable, an integer variable, called backward time. That's because I can't use the same variable to control two different things if I want them to actually mean two different things. If they both mean the same thing, you can just use the same variable. This one we move in reverse, wait for the backwards time, turn the motors off, wait 1 second. Void right turn, create a variable called right turn time. To turn to the right, you want your right motor to go backwards, so that's why the value is negative, and your left motor to go forward, so that's why the value is positive. Again, we wait for the amount of time that we set in our variable. Turn the motors off, wait 1 second. Left turn, the same thing. Create its own variable called left turn time. This time the right motor is going to go forward, left motor is going to go reverse. Both of these turns are what we refer to as a point turn, and then we wait 1 second and wait for the next line of code. So when it comes down to writing our task, all of these functions were created before we even started our main task. So just take note of that. Once we start the main task, we set forward, so we're calling the function. This 1000 inside the parameters automatically gets set to what forward time is equal to. So forward time is now equal to 1000. Whatever number I type in within those parentheses to set up the parameters goes to equal the value of that variable. So I go forward for 1 second, backward for 1 second, right turn for 1 second, left turn for 1 second. And I could continue going through and type right turn, and I can turn right for 2 seconds. Okay? Now, how many lines of code, if I didn't use the functions here, how many lines of code would it have taken to just straight program that out without any functions? Well, we can go back and count. So forward, the function forward is made up of 1, 2, 3, 4, 5, 6 lines of code. Backward is 1, 2, 3, 4, 5, 6. So we can say they're all 6. So that would be 6, 12, 18, 24, and 32 lines of code right here. Now you might be saying, well, Mr. Pete, we've got 1, 2, 3, 4, we've got from 8 to 48, so that's 40 lines of code, and you say I'm only putting 32 in here to program all that. Well, what if you were telling the robot to go through a maze and you constantly had to tell it to go forward and backwards, right turn, left turn, forward, forward, backwards? Okay? You would have a really complex code, and your code would get longer and longer and longer, and eventually it will get so long that when you go back to check and see when things are starting to mess up, it'll be hard to do because you can't go back and easily find it. This way, all you have to go back and do is look at how many times you went forward, backwards, right turn, left turn. When it comes to using the shaft encoders to make sure something goes a certain distance instead of just using time, programming the shaft encoders, you've got to do a lot of comparison. This is what the shaft encoder program looks like. Okay, so a lot of comparisons. 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code to create the move until distance, and we say distance in degrees, and then we can say set your right encoder until the number of degrees is met. It's going to run the motors forward. And when we come down here, 3 lines of code. If we need to keep returning and making it move and turn to the left or turn to the right, using those functions is going to make your program a whole lot more understandable. And you can do a lot more customization to the functions. So let's say you wanted to calculate the area of something. You could write a function to calculate the area of a circle you just traveled in. If you want to calculate the area of a triangle, if you want to calculate the length of the hypotenuse using the Pythagorean theorem, you could write functions to do all that. And let's say you had to do that multiple times inside the main task, it'd be easier for you just to write the function one time and then call the function whenever you needed it, instead of having to retype those lines of code over and over every time you had to do that simple behavior. So it's taking all these basic behaviors and making a simple behavior called point turn left. Hopefully that gives you an intro to functions, and you can see their usefulness in everyday robotics and machine control. Not just robots that we drive around, but machines like washing machines and other items in our household that do simple tasks but require basic behaviors to build those simple tasks. And then those simple tasks eventually build on to become complex behaviors, like, all right, I want this machine to build a gear for me and machine it and finish it. Well, what are all the simple behaviors it needs to do? And then break that down into its basic behaviors. And if it's a simple behavior that's being repeated a lot of times, then you probably want to write a function for that behavior. Thank you guys for watching the video.